The purpose of this hands-on laboratory and tutorial is to introduce the very useful and versatile breadboard, also called a protoboard. This video will help you use the breadboard to build electrical and electronic circuits. As you watch this presentation, you can stop and go back to any part you wish to repeat. In this hands-on laboratory activity, you will gain experience with the breadboard by building a circuit that uses a variety of components, including wire, an integrated circuit, resistors, a capacitor, and a diode. This lab is designed to be compatible with the Electronics Learning Lab from Radio Shack, or you may do this lab with a protoboard such as this one. Yours may look a little different. Most any style protoboard will work well. We will build a circuit that will blink an LED or light-emitting diode. The electronic parts for this project include a 1K resistor, which has a color code of brown, black, red, gold, a 4.7 K ohm or 4700 ohm resistor, which has a color code of yellow, violet, red, gold. You will also need a 10K resistor, which has a color code of brown, black, orange, gold. Remember, 10K is the same as 10,000. The color code for 10K resistors is brown, black, orange, gold. Brown is white, black is 0. The third band, which is orange, for 3, which means 10 raised to the third power, or 10 times 10 times 10, which is equal to 1,000. So these resistors are 10 times 1,000, or 10,000 ohms. The last stripe is called the tolerance band. Common resistors today use 5%, which is a gold band. It is rated plus or minus 5% of the value. 5% of 10,000 ohms is 500, so it is guaranteed to measure somewhere between 9,500 and 10,500 ohms. The circuit needs a 10 microfarad electrolytic capacitor. A capacitor holds an electric charge. Notice how one of the leads is marked as negative. We also need a light-emitting diode of any color. Notice how one side of the LED is flat. This marks the cathode lead wire on the LED. The cathode is normally connected to the negative side of the battery or power supply. The other lead is called the anode and is connected to the positive side of the battery or power supply. By the way, never hook an LED to a voltage higher than 3 volts without a resistor connected in series with the LED, or it will be damaged. The heart of the circuit is the 555 timer integrated circuit, or IC. This type of IC package is called a dual inline package, or DIP, because it has 2 rows of pins. Notice the pinout diagram for the 8 leads or pins. Like most DIP packages, ICs, pin number 1 is located in the upper left-hand corner next to the impressed dot. Also, the end next to pin 1 usually has a notch. The 555 IC is a versatile and popular chip used in numerous applications involving analog timing and clock circuits. It contains transistors, diodes, and resistors already assembled in an integrated package. You will also need a source of 6 volts. A 6-volt lantern battery is a good source of direct current for experiments. You can also connect 4 1.5-volt batteries in series to get 6 volts. The Learning Lab kit has 6 1.5-volt batteries in series to give up to 9 volts. Notice how by tapping into the different places in the battery bank, you can get 1.5, 3, 4.5, 6, 7.5, or 9 volts. Instead of batteries, you can also use a variable DC power supply, similar to this one, set to 6 volts. You will also need some jumper wires. A jumper wire assortment like this is convenient, but not necessary. You can also cut pieces of wire off a roll of 22 or 24 gauge hookup wire. A good and cheap source of hookup wire is twisted pair network wire, such as Cat5 or 6 Ethernet cable, or telephone wire. To make jumpers, you need a wire stripper. Short jumpers can be made by sliding the separated insulation before cutting the wire. Another tool that is helpful but not essential is a pair of needle nose pliers. They help with inserting leads and wires and with bending wires. Now, let's begin building the circuit. First, install the 555 IC on the breadboard. Make sure pin 1 is in the upper left-hand corner of the IC chip. Be sure that the pins on the IC are straight. If the pins stick out towards the sides, You can straighten them by rolling the IC on a tabletop. Be careful not to bend the pins too far inside. Step 2. Connect pin 4 to pin 8 on the IC. You can do this with a short jumper wire. Step 3. Connect pin 2 of the IC to pin 6. Again, you can use a short jumper wire for this. Step 4. Connect pin 8 of the 555 integrated circuit to plus 6 volts on the breadboard. If you are using the Learning Lab, 6 volts is available on top of the breadboard. In this picture of the breadboard on the Learning Lab, a white wire was used because it was the correct length to reach. Ideally, it might be a red wire for positive. If you are using a different style protoboard, your 6-volt power supply will be different. It will be connected to the power strips on the side, shown here as a red wire. Step 5. Connect pin 1 of the 555 integrated IC chip to the ground connection on the breadboard. If you are using the Learning Lab, it is the strip along the bottom of the breadboard. Here we show a red wire used because it was the correct length to reach it. Ideally, it might be a black wire or blue wire for negative. If you're using a different style protoboard, your ground or negative connection will be different, like to the power strips on the side, shown here at using a blue wire. Step 6. Connect R1, the 4.7 k ohm resistor, from pin 7 on the 555 IC to 6 volts. The purpose of R1 is to work with capacitor C1 to control the pulse rate of the 555 timer chip. The pulse rate is also how many times per second or minute the LED will blink. Here it is on the breadboard with the power strips on the side. You can connect the 4700 ohm resistor from pin 7 to the 6 volt power strip, or since pin 8 is already connected to 6 volts, you could connect the 4.7 k resistor to pin 8 and the other end to pin 7. It is the same. Step 7. Connect R2, the 10 k ohm resistor, from pin 6 of the 555 IC to pin 7. The purpose of R2 is to control the width of the pulses generated by the 555 RC, or how long the LED stays on for each blink. Here it is on the breadboard with power strips on the side. Step 8. Connect the cathode of the light-emitting diode LED to pin 3, the output pin of the 555 IC, and the anode to an empty 5-hole strip. Remember, the LED cathode lead is next to the flat side of the LED case. Next, connect the anode of the LED to the positive 6-volt power supply through the 1 k ohm resistor. Step 9. Connect the 10 microfarad capacitor between pin 1 and pin 2 of the 555 IC. Make sure that the negative lead of the capacitor is connected to pin 1 of the 555 IC. On most electrolytic capacitors, the negative lead is marked with a stripe and minus signs printed on the side. Step 10. Now we can connect the circuit to the power supply or battery and test it. If you're using the Learning Lab, all you have to do is turn it on. If you're using a breadboard with power strips on the sides, you need to connect the power strips to the power supply or battery. If you're using a protoboard with 2 power strips on each side, you may need to connect the positive strips on each side and the negative strips on each side with wires, like here shown with red wires. If your LED does not blink like this, you should recheck your wiring. All of the pins on the 555 IC should be connected to something except pin 5, which is not connected to anything. A common mistake is to put the LED in backwards. The cathode lead, which is next to the flat side, should be connected to pin 3. Also, make sure the capacitor is connected correctly with the negative lead next to the stripe with minus signs. Make sure it's connected to pin 1. If it is blinking, congratulations! You are now an experienced user of a powerful tool, the electronic breadboard.